This is Tony George. I'm the coordinator for the IOTA R-OTE volunteer group. And in this session, our second training session, we are going to demonstrate a new version of R-OTE, R-OTE 4.5.9. And we're going to analyze a file contributed by Ted Swift in our group, which contains an integrated video CSV file and some interesting characteristics that we can show in our R-OTE analysis. So I'm starting with RStudio open. We're going to load the version of R-OTE by setting the working directory. So we choose the directory, and the directory that we're going to use is R-OTE 4.5.9. It has some improvements to error bar analysis and some other minor improvements. And so we're going to select this folder. And after we select the folder, we see that the contents of the folder are displayed here. And we want to select the UI.R code, which is the user interface code that we use to initiate R-OTE in RStudio. And once that code is displayed in the box, we're going to press Run App. Run App initiates the Google Chrome graphic user interface. So this is Google Chrome initiating, and this is our normal starting screen in Google Chrome. You can use Internet Explorer too. They're interchangeable. So our first step is to select a file, and we press the button. Our file Internet Explorer box opens up, and I've got it already set to the Ted Swift example file of Polyxo, recorded on November 12th, 2016. And we'll open this file, and we see a occultation light curve. We want to see if there's any secondary star light curves in this CSV file, so we press this Show Secondary Light Curve button, and sure enough there is. And the secondary light curve shows that there's some attenuation of brightness due to atmospheric extinction, maybe a cloud or something that has affected the light curve. So we'll end up analyzing this light curve by normalizing it to the secondary light curve. So the first thing what we want to do after loading the file is we'll look at the basic files that we received on this particular event. Typically we'll have a path map. Here's our path map. Shows a magnitude drop of 1.0. We'll consider that in our analysis. We have the original observer report, which is done in an Excel spreadsheet format, and we see in this report that the observer used a PC-165 DNR camera. It was an NTSC format, and it was operated at an integration of 4x fields, or 2 frames. There's 2 fields per frame. We'll look at the camera delay correction and the VTI correction, and we'll verify those as we proceed with our analysis. This observer also produced an R-OTE report, and in that report he gives us the DNR times for the event and some error bars. It indicates that it is an NTSC camera, and he's applied the delays appropriate in R-OTE. We may return to that part of the report as well. And then we have the light curve, which we've already opened up. This is a LiMovie file format light curve.